Welcome back to topic 41 for Algebra 2, Solving Rational Equations. In part 1, we're going to define what a rational equation is, solve rational equations, and define and identify extraneous solutions. So let's first define what a rational equation is. A rational equation is an equation that contains a rational expression. So pretty self-explanatory there. If we look at these examples that are listed below, it might seem pretty obvious on how to solve them, thinking back to what we did in Algebra 1 to solve these by cross-multiplying. However, here we want to take what we learned about rational expressions and use that in order to solve this. So if we were to cross-multiply, what we're really doing is we'd be multiplying both sides in example number 1 by x plus 4. Now this x plus 4 is our least common denominator. And I know in past videos I identified this as least common denominator or the least common multiple. So when you think of the least common multiple, think of that as like an umbrella term, and the least common denominator is the least common multiple, but it's just specifically for the denominator of an expression. So because this is really 2 over 1, we don't really need to take into account the 1 because 1 is humble, it's always there. But we do want to acknowledge the x plus 4. So since that is my least common denominator, what I'm going to do is I'm going to multiply both sides by x plus 4. And that's what we would be doing if we were cross multiplying. This is like the math behind it. It's just sometimes people don't always write it. On the left-hand side, since we have an x plus 4 in the numerator and then 1 in the denominator, it just cancels. So we'd be left with 1 equals 2 times x plus 4. We can apply the distributive property to get 2x plus 8. Now we have this linear equation. It's a two-step equation, so all we have to do is solve for x. So subtract 8 on both sides. Negative 7 equals 2x. Divide both sides by 2. Easy peasy. X equals negative 7 halves. So that's our example, or that's our first example, and how to solve for x in that first rational equation. If we look at example number 2, we have 1 divided by x minus 3 equals 5. Again, this 5 is really just over 1. And the least common denominator that we have here is x minus 3. So similarly to example number 1, we're going to multiply both sides by x minus 3. What we do to one side, we have to do the other in order to keep it balanced. On the left-hand side, we have an x minus 3 in the numerator, 1 in the denominator. So we are just left with 1. Now 1 equals 5 times x minus 3. Again, apply the distributive property. So we get 5x minus 15. So now we can solve for x. Add 15 to both sides, get 16 equals 5x, divide both sides by 5, x equals 16/5. Perfect. Now, in the previous videos, we would identify restrictions on the domain. So we'd have to look at the denominator to make sure we had values, or we acknowledged values that x can't equal. So in problems such as these, we don't need to identify restrictions on the domain because there actually is a solution for x. And the domain stands for all the values that x could equal. It would be all real numbers except x can't equal blah, blah, blah. But in this case, we actually have values for x. We're going to take a look in the next example and identify something called extraneous solutions, which could kind of twist, I guess, what our answer could or could not be. So moving on, what is an extraneous solution? An extraneous solution is a value that makes the denominator of the original equation equal to 0. So we don't want to have 0 in the denominator. That would make our value undefined. So notice here how we have a little bit more complicated example than the first two. 1 divided by x minus 5 plus x divided by x minus 3 equals 2 divided by x squared minus 8x plus 15. So first step, what we want to do is we want to identify what the least common denominator is and then multiply that to each side. So we need to take into account all of the values in the denominator. We have x minus 5. We have x minus 3. And if we look on the right-hand side, we have x squared minus 8x plus 15. But actually, if we factor that, we get x minus 5 times x minus 3. So we don't need to rewrite it, but just x minus 5 times x minus 3, that is our least common denominator. So like we did previously, we want to multiply this least common denominator to both sides of our equation. Now notice on the left-hand side how we have two terms. So we would need to distribute. What I personally like to do is I like to multiply my least common denominator to every single term. It's just easier for myself to visualize instead of having to think about distributing. So I'm going to rewrite our equation and just leave a little more space. So we have 1 over x minus 5 plus x over x minus 3 equals 2 over, and I'm going to rewrite this denominator in factored version. X minus 5 times x minus 3. Now I'm going to multiply every single term by that least common denominator. Because again, we want our equation to be balanced. Okay, so here what we're going to do is we're going to now simplify. So notice how we have an x minus 5 in the numerator and 1 in the denominator. Reduces to 1. X minus 3 in the numerator, x minus 3 in the denominator, that value reduces to 1. And on the right-hand side, we have x minus 5, x minus 5, x minus 3, x minus 3. So if I were to simplify this and rewrite it, I'd be left with 1 times x minus 3, which is just x minus 3, plus, now x times x minus 5. So that simplifies to x squared minus 5x equals 2. So now I'm left with a quadratic equation because my highest power is 2. I'm going to rewrite this in standard form. X squared minus 4x minus 3 equals 0. So what we need to do now is, oops, that equals 2, not 0. What we're going to do now is I'm going to set the equation equal to 0. I was jumping ahead of it. So that I can factor and use the zero product property to identify what my possible values of x can be. So I'm going to subtract 2 from both sides and get x squared minus 4x minus 5 equals 0. Now I can factor the left-hand side. So what multiplies to get negative 5, but adds to get negative 4? Well, that's x minus 5 and x plus 1. So here, if I use the zero product property, that says that if you have a product of values that equal 0, at least one of them has to be equivalent to 0. So either x minus 5 equals 0 or x plus 1 equals 0. In order to make those statements true, then either x would be 5 or x would be negative 1. But remember what I said beforehand, how we have to think about extraneous solutions. So could either of these two values, 5 or negative 1, if I plug them back into the original equation, could that make any one of the denominators equal to 0? Well, if I look back at my original denominators, I have x minus 5, x minus 3. So if I think about those denominator restrictions, I know that x can't equal 5 and x also can't equal 3. So looking at my two possible solutions, 5 and negative 1, I can't include 5 because that would make one of the denominators equal to 0. In other words, we would say that x equals 5 is extraneous. So the only solution is x equals negative 1. Let's try another problem. Here we have 5x divided by x minus 2 equals 7 plus 10 divided by x minus 2. So again, this 7 is really 7 over 1. If I want to identify what the least common denominator is, this one is pretty straightforward. It would just be x minus 2. So I'm going to multiply my least common denominator to every single term in order for my equation to be balanced. So I'm going to rewrite my equation. 5x divided by x minus 2 equals 7 plus 10 divided by x minus 2. And my least common denominator that I'm going to multiply is x minus 2. You get an x minus 2, you get an x minus 2. Everybody gets an x minus 2. Now we're going to simplify. So since we have an x minus 2 in the numerator and 1 in the denominator, that reduces. I can't reduce anything with my term of 7, so we're just going to leave it. And we have x minus 2 in the numerator, x minus 2 in the denominator, so that cancels. So this is eliminating my denominators in this case. And what we're left with is just a linear equation. So I have 5x equals 7 times x, or 7x, minus 7 times 2, or 14, plus 10. So I'm going to get all of my like terms on one side, and all of my variables on one side, and all of my constants on the other. So combining my variables, I get negative 2 by bringing over that 7x. And then negative 14 plus 10 gives me negative 4. Divide both sides by negative 2. And x equals 2. But hold up a minute. We have some denominator restrictions. So if we look back at our least common denominator that we had, x minus 2, we know that if we plugged in 2 for x, that would give us a 0 in the denominator. So x can't equal 2. However, that's the only option we have here. So because that does not work, and because this 2 is extraneous, then we would just say that there is no solution. There is no possible value for x that would make the statement above true. Moving on to example number 2, we have 3 divided by x minus 3 equals x divided by x minus 3 minus x divided by 4. So the least common denominator that we have here is not only x minus 3, because we see it in those first two terms there, but we also need to account for the 4. So the least common denominator is the product, x minus 3 times 4. So I'm going to rewrite my problem and just leave a little space in between each term. Now I'm going to multiply every single term by my least common denominator. Now I can simplify. So because there's an x minus 3 in the numerator, 1 in the denominator that cancels, again in the second term, and we have a 4 in the numerator and a 4 in denominator on the third term. So what we're left with is solely the numerators. Our new denominators have just reduced to 1. So we have 3 times 4, which gives us 12, equals x times 4, or 4x, minus x times x is x squared, x times negative 3 is negative 3x. So I'm going to combine my like terms. If I distribute this negative, I'll get negative x squared plus 3x plus 4x gets me plus 7x. Now if I write this in standard form and get all my like terms on one side, I'm going to personally choose to move the quadratic term, the x squared, so that way I don't deal with a negative x squared. It's going to make it a little easier in factoring. So I'm going to add x squared to both sides and also subtract 7x. So on the right hand side, I'm just going to be left with 0. So I'll have x squared minus 7x plus 12. I can now factor that. So what two values multiply to get to positive 12, but when you add them, get to negative 7? Since they're adding to a negative number and they're multiplying to get a positive number, I know both of them are going to be negative because a negative times a negative is a positive. So I'll get x minus 3 and x minus 4. Now I can use the zero product property. So x could either equal 3 or 4. But let's look at any denominator restrictions. If I look up top, the 4 is kind of irrelevant. What I really care about is anything that deals with a variable. So the x minus 3. So with x minus 3, this is telling me that x can't equal 3. So that 3 is extraneous. So my solution is just x equals 4. And that was part 1 of topic 41 for Algebra 2, Solving Rational Equations. Thank you for watching.